Hello everyone. So this is a problem from projectile motion. Let's read through the problem once. A commander fires a shell at certain angle from the point A, which clears the cuboidal shaped building of dimensions 20 into 15 into 12.5 meter cube in its diagonal plane. PQ is the one of the diagonals. Shell just clears the roof diagonally at the top at the points P and Q and falls on the other side of the building at the point B and makes 45-degree angle with the horizontal at P and Q as shown in the figure. If the range AB on the ground of the shell is n times root 3 meters, then we have to find the value of n and we have to take G as 10. So here if I call this point as R and this point as S, so clearly this PQRS plane will lie in the plane of the projectile. So let's redraw this diagram in 2 dimensions. So if this is the ground, let us say the ball is fired from here, the shell at some initial velocity u at some angle theta, and if it goes like this, let us say it goes like this, and we can say that this point is A and this point is B, and somewhere at the top 2 points P and Q will be there. So let us say this point is P and this point is Q. This height is given. This height is 12.5 meter. This height will be 12.5 meter also. So if I draw a horizontal line like this from P to Q, the motion between P and Q is also like a ground to ground projectile only. And if the velocity at this point P is V, this angle is 45 degree is what is given in the question. So V will have 2 components. One will be Vx, the horizontal component, which remains constant in a projectile motion, and one will be this vertical component of velocity Vy. So this changes with time and height. So this is 12.5 meters. Now initially we can write u in components. One along x-axis, this is the x-axis, this will be u cos theta, and this vertical component of u can be taken as u sin theta. So this is uy, and this u cos theta, it remains constant. So this let us say it is ux and vx both will be same. So between P and Q we can say that the range is since this is 15 meter, this is 20 meter, the diagonal SR will be equal to the diagonal PQ, and both will be equal to SR can be easily calculated under root of 15 square plus 20 square. So this will be nothing but 25 meter. So this PQ will be 25 meter only. So if I apply the formula for range between the points P and Q, then the range will be equal to 25 meter, and this will be equal to V square sine 2 theta, meaning sine 90 degree, and divided by G. The value of G is given equal to, we have to take it as 10. So sine 90 degree will be 1. So V square will be 250, or we can take V as 5 root 10. We can take V. Now from here we can calculate the horizontal component of velocity Vx, and Vx will be nothing but V cos 45 degree. So V we have calculated, it is 5 root 10, cos 45 degree will be 1 by root 2. So on cancelling out, this will become 5 root 5 meter per second. And since the horizontal component of velocity remains constant in a projectile motion, so this Vx we can take as u cos theta only. So we get the value of u cos theta as 5 root 5. So let us call this equation number 1. Now if we consider the motion perpendicular to the x-axis along the in the vertical axis, along the vertical axis, then we can write Vy square will be equal to Uy square minus 2gh and Vy will be V sine 45 degree. So V sine 45 degree meaning V by root 2. So Vy will also be equal to Vx only because we have 45 degree there. So Vy we can take as equal to Vx. So this will be 5 root 5 whole square. And this will be equal to Uy square minus 2 times g is 10 and height at that point is 12.5. So on solving, this will be 125, clearly it can be shown, and that is equal to Uy square minus this will become 250. So from here we get Uy equal to under root 125, oh sorry, not 125, this will add up 125 plus 250, so this will be 375 under root. And 375 under root can be written as 5 root 15. You can verify this. So Uy is 5 root 15 meter per second. So Uy is nothing but U sine theta. So U sine theta will be 5 root 15. We take it as equation number 2. And since we have to find the value of capital N, and the range is n root 3, the range on the ground, that is EB. So we will write the formula for range on the ground, which will be U square sine 2 theta by g. So the range is U square sine 2 theta by g, and the range is n root 3. So this we can write as U square, and sine 2 theta, if I break sine 2 theta in 2 sine theta cos theta, so 2 I will write separately, and U sine theta, and one U I will club with cos theta, so into U cos theta divided by g. This I have done because we can directly substitute the value of U sine theta and U cos theta. So 2 times U sine theta is 5 root 15 and U cos theta is 5 root 5 divided by, take the value of g as 10. So 5 into 2, 10 will get cancelled, and so we have n root 3 equal to 5 and root 75. So 75 can be written as 25 into 3, and 25 will come out of the root as 5, and 5 into 5 will be 25. So this will become 25 root 3, and on comparing, root 3 will get cancelled out, so n will become 25. So that is the value of n. So that should be the answer. So that is the solution to this problem, a direct problem. Only thing you have to do is you have to convert this 3D diagram into a 2D diagram, and for that we have to take a plane in the cuboid which lies in the plane of the projectile. So here this plane will be PQRS. So that is it. Thank you very much.